All right, so here is our 8-3 notes, similar by side, 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 and side, angle, side. So remember, similarity is different than congruency, and we've already used these variations of these theorems for congruency, but remember that we are dealing with similarity in these notes. So our essential question is, what are two ways to use corresponding sides of two triangles to determine the triangles are similar? So this first theorem says side, side, side similarity theorem. It says if corresponding side lengths of two triangles are proportional, then the triangles are similar. So we already told you if the triangles are similar, then the corresponding sides are proportional, but this is saying the converse of that. So if we know that the side lengths are proportional, then we can call the triangle similar. So there's your theorem. I hope you are taking notes because you're really going to want this written down when we have our test for the end of the chapter. And here is our first example. It says, is either PQR or STU similar to VWX? So we're going to say that corresponding sides would be similar. We are looking at VWX, which is the smallest here, this triangle that I've circled in red. So we're going to have to set up two different proportions and verify that those proportions are equal or not. So we're going to go ahead, let's compare it to the larger triangle first. So I'm going to say VX, which is the longest side of that triangle, over SU. So I'm taking the longest side of this triangle and the longest side of this triangle, and I'm going to compare it to the other two sides. This is an isosceles, if you can't already tell this. And then so I have, let's say, WX over TU. So this would be 12 over 20 needs to be proportional to 8 over, oh, I'm sorry. Whoa. 12 over. So VX is 12, SU is 30, is going to be proportional to 8 over 20. So we're going to go ahead and reduce these. I notice my first one I can divide both by 6, so I'm left with 2/5. And on the one on the right, I can divide both by 4, so I'm left with 2/5. So these are proportional, which means that triangle, I'll change colors here so you can see a little bit better. Triangle VWX is similar to triangle STU. We just proved that. So now we're going to go ahead and do it to PQR. So same thing. We're going to go the largest side, so VX over the largest side of PQR, which would be PR. And you should always write the letters in the same order as they are written in the description of the triangle. So VX, because V is the first letter in how we labeled my triangle. Same with the P and the R. So VX over PR needs to be equal to, let's just keep WX for the sake of consistency, and then we'll go WX and we'll go QR on this one, QR. So let's set this up. VX again is 12 over 16 is going to be equal to 8 over 12. Some of you that are more mathematically inclined might see this right away and say there's no way that's equal. If I reduce these, 12/16 ends up being 3/4, and the other side would be 2/3. So these are not equal, so these are not similar. Okay. All right, so find the value of X on this triangle that makes these two triangles congruent. So XYZ is, or sorry, not congruent, similar. So in order to be similar, their side lengths would be proportional. So we're going to set up a proportion, but we have to be kind of smart on which one we set up here because we want to make sure that we have enough information to solve for X. So I'm going to start with XYZ, the smaller one. And let's go ahead and pick XZ, because it looks like XZ coordinates with HK, right? Those are the longest of the two sides. And HK is 30. I'll just write underneath 30, and then XZ would be X minus 5. And now we're going to want to pick a side that has, that both have values for X, so we don't have to solve. We can solve a little bit easier, in my opinion. Or they don't have a value X to solve for. So I'm going to use this side and this side right here. So we're going to go ahead and use XY and HJ. So that's going to be 3 over 15. So now we can go ahead and cross multiply to solve this. So I'm left with 90 equals 15 times X minus 5. So I'm left with 90 equals 15X minus 75. So I add 75 to both sides. And I'm left with, 165 equals 15x, which would be, if I divide both sides, if I get x equals 11. And maybe if you were doing this on a test or quiz, you'd want to go back up and double check and make sure that it works for both values of x in the original triangle. Okay. Almost done here. So side angle side theorem is very similar to when we were talking about congruency, except it says if an angle of one triangle is congruent to the angle of the second triangle and the lengths of the sides including these angles are proportional. So we're not talking about congruency, we're talking about proportionality. Then these triangles will become similar triangles. So let's go ahead and look at this example to explain that a little bit better. It says the diagram is a scale drawing of a triangular roof truss. So this is something that architects or contractors would definitely need to know. It says the lengths of the two upper sides of the actual truss are 18 feet and 40 feet. The actual truss and the scale drawing both have an included angle of 110 degrees. Is the scale drawing of the truss similar to the actual truss? Explain. So we know that the included angle is 110 on each of them. So now we just need to prove that the sides are proportional. So I'm going to take the longer of the two sides, so 10 inches over 40 feet. And then it'd be 6 inches over 18 feet. And remember, we're comparing them to the ratio. I mean, we're really saying like 18 and 40 is at the same ratio as 6 and 10. So the fact that we have inches and feet doesn't really matter in this case. If that makes you feel uncomfortable, you could change the bottom two numbers to be represented in inches, but it's not going to change. Okay, so we're going to go ahead and reduce these. You should be able to tell really quick. This would be 1/4. This would be 1/3. So these are not, this is not a scale drawing, because a scale drawing is actually similar, using similarity to draw the differences. Okay, so the last one, or this isn't even a problem. So this is just the summary. It says the three, well, we talked about this one, triangle similarity theorem. So the angle. So if we know that two angles are congruent, the third would have to also be congruent, which makes the two triangles similar. That's the one we did last week. This center one just says if the three sides are all proportional, then the triangles are similar. And then the last one says if the sides are proportional and the included angle is congruent, then the triangle is similar. So you can go ahead, think about when we're talking about similar triangles, we're talking about the sides being proportional and the angles being congruent. So different than the congruency unit or module on triangles.